and dear to all of us, and always seeming to be um, running faster than we're catching up to it. So, what's intriguing, Rainer, about your patent filing is that the graphs that result are self-documenting. And that's something we certainly want to hear about. But we're looking forward to just getting a general overview of what you have been putting together here. Um, can we start with a bit about your background and how you got into this?
Um, sure. What it is that, hold on, let me pop up this slide here. Okay, so this is just what I'm going to cover so that you kind of know where I'm going with this conversation. I
Sure.
do have to explain the background.
Hmm.
Otherwise, a lot of it's not going to make any sense at all. So I've been doing IT for about 34 years. 11 years I spent in medical, developing medical applications. Sorry, take that back. Mostly on clinical side, developing business office and eventually doing electronic medical records and those type of things. Did cybersecurity for about 8 years, application development as well as network security and forensics. Spent 4 years as a webmaster doing that, kind of just relaxing. It was just way too easy. And for the last 7 years, I've been running a virtual and augmented reality lab. Um, at and at night, I do other things, um, and I happen to be doing, this for the past 7 years. Um,
So it's interesting that you are running this VR AR lab, which tends to be focused on the presentation layer, and yet you've got this patent filing that has to do with the plumbing. I mean, it seems like you're bridging both here.
um, well, I was using the Unity game engine since 2009. And in 2015, they said, hey, we need somebody to run this virtual augmented reality lab. And I said, yeah, okay, I've got experience doing that. Um, and so I'll get into what I'm trying to accomplish and how I got here and all those things. I'm going to answer your question.
Okay.
So what I'm trying to accomplish is get a humanoid robot that can understand and work and behave in the world as we do, without the brain chemistry and emotions. Okay, what I figured out is that brain chemistry and emotions is just bad news. Um, because you bring things into the table that we're not very good at controlling. And the last thing you need is for that to be in robots. Uh, so people say, well, how are you going to do this? You can't, how are you going to get a robot, a humanoid robot? Those things are expensive. But there's so many things that you can do in a game engine these days that you can actually simulate all of it. You really don't need a real robot. I mean, eventually you do, right? Once you kind of get more stuff working. But in the meantime, a lot of it can just be done in a virtual world. So the settings, those type of things. Um, and so that's what I'm trying to do at the moment is kind of get this. Now, there's this kind of interesting, all the advances that are happening. Boston Robotics and all these other robots are coming out. And eventually someone's going to get something that can move around by itself, just as we do. So there's no reason why, excuse me, that we can't. Ooh, turn this off. There we go. Sorry, that's better. All right. So why am I doing this? And let's get to answer your question. In 2015, there were two movies that came out, right? Ex Machina and Terminator Genesis. And I'm a big sci-fi fan, so I watch all of the sci-fi movies that are good, and especially the AI pieces of it. And about the same time, what they had is they had a lot of people in the media kind of saying that AI was going to take over the world, that AI is going to take over our jobs, that this was kind of like it's going to prevent itself from being turned off, those kind of things. And I'm like, wait a minute, what did I miss here? When did this happen, right? And I thought, no, this can't be right. I mean, this is not my field, not artificial intelligence, but I didn't think we advanced that far. So what I did was I kind of like took a deep dive to figure out what all this stuff was, right? So I read books, went on YouTube, took a bunch of courses, listened to all these people. And after a while, I figured out, you know what? This isn't the artificial intelligence that I'm looking for. I mean, everybody's doing a lot of good work, which is great, but this is kind of what I was expecting. This is the artificial intelligence that I always kind of like grew up with. As a kid going to the movies, I'm like, this is artificial intelligence. A robot with a human mind, that It's almost like us. Not perfect, sci-fi. They got a lot of artistic leeway there to kind of create whatever they want. But, I was expecting more of this. So now what, right? So now I find out the truth that the artificial intelligence that you're talking about is not what I expected. It's okay. I mean, a lot of good work is being done. I'm not going to criticize that at all. But it's not the AI that I was expecting. So in about 89 or so, my dad had a traumatic head injury, and that really kind of scrambled his brains for a while. And I did a lot of research on the brain to understand, how the brain works. Like, why is he having so many issues? Why is he having so many problems? And I really got interested in learning about all these pieces, right? So people are always talking about, all the parts of the brain, what we know, what we don't know, those type of things. So I'm like, okay, I got some free time. I got some skills. Maybe I can actually figure out how to create, the type of AI that I was thinking about. I mean, there's a lot of things that I've done over the years where I had no idea what I was doing when I started. And eventually I can figure it out. So somehow I turned out to be a Swiss Army knife as far as technology goes. And just lucky, that I'm able to do that. So my approach is kind of like, well, I'm going to reverse engineer the brain, not replicate, the brain using a computer. I'm not going to worry about how the computer's going to do it, because who knows if the computer ever can. Just go around some core concepts, sensory information, language, storage, those type of things, and don't worry about creative thinking. So, it's not like I had any expectation on how to go about doing this, right? It was kind of like, well, I need to do lots more research and lots more homework, and hopefully I can get this done. So from March 2015 to December 2017, I kind of take a look at all the different artificial general intelligence projects going out there, right? Numenta, OpenCog. There's lots of other projects, and I'm looking at all their work and the documentation, those type of things. And I'm really not seeing things that resonate with me as far as the approaches. I mean, once again, lots of good work being done. I mean, this is definitely something hard. Everybody's got, their kind of like idea on how it should be done. But I'm like, okay, this isn't happening, at least not for me. I didn't see anything else. Well, these guys have got it. So, I have a tendency of doing a lot of drawing and sketching and, all kinds of things. So graphs and pictures, and try to, just on paper. And I carry a notebook around with me, and I had a lot of false starts from a technology standpoint. It's kind of like, I'd come up with some stuff and throw around some ideas and still not getting anywhere. And so that was kind of like disappointing. It's like, well, here I am thinking that I could do this thing, and maybe I can't. So in January 2018, I kind of figured out, well, in order for a computer to understand the world as we do, it has to live in it. And a lot like the Truman Show, where you're setting up these scenarios, the computer is encountering these things, right, in robot form, and you kind of see what the computer thinks. How's it figuring it out? And that's the way I only think that you can get something that understands us. You can't just infuse that understanding, right? You have to live it, right? It's like reading a book on mountain climbing. You could read all you want, but until you're actually doing it, right, you have no idea what it's like to mountain climb. So I spent a lot of time thinking about how I'm going to do the Truman Show. In June, I'm still having a problem with how to store and organize that knowledge, because a lot of it's there. There's just so much information that we have stored that we take in, all the thinking, all of that is like, all right, this is still a problem. So I decided, okay, you know what? I'm gonna create a baby simulator, try to do the baby's mind from day one. So some people think you do the 3-year-old, I guess that works for them. But I said, well, I'm going to start from day one and see what that looks like. So, what kind of information does the simulator create for the newborn to process? And it's incredible, right? You've got sensory information, expressions, body language, emotions, actions, all these things happening, right? Sequences, stages, and there's no words whatsoever, right? So try to develop a system now. You're thinking, okay, with absolutely no language at all. Those are just sounds to the baby, right? There's a lot of things, just smells, just touch, right? No understanding whatsoever of what's going on. So how does the baby make sense of any of this? There's conditions, there's words and phrases. I mean, it's kind of miraculous that, we kind of get to the point that they turn into us. There's just so much noise there. So what's happening in the newborn's mind is that these actions are happening. There are states that change. Hold on, I need to make myself a little smaller here. There's states that changes. So, baby poops their diaper, it smells bad, they start crying. Mom appears and stops crying because the baby knows the diaper is going to get changed. Sometimes when the dad shows up, baby continues to cry because it knows that dad's not going to change the diaper, right? Dad's going to call mom and the diaper's going to get changed, right? And so, when you start to kind of like do these kind of like diagrams where you start to understand what's happening in the baby's mind, right? And you start living this. So I started living a baby's life constantly. When I'm out and about with my wife on the weekends, she says, "Are you distracted by something?" I says, "Yeah, I'm doing the baby thing." you know, and trying to understand all the brain chemistry, and the emotions and everything's going on. And this is constantly just going around in my head for months, to understand this is how a baby lives. And what's crazy is that I kind of come up with this idea that, we're sensory processing biological state machines that are driven by brain chemistry. Now, not everybody's going to like that idea because they think that, we're driven by our thoughts, but a lot of it really is just brain chemistry. And so, a lot of times when logically, you shouldn't do something, okay, like if you put your Mr. Spock hat on, you go like, nah, that's a bad idea. Your brain chemistry tells you to do it anyway. Okay. It's an interesting thing. So how do you map all of this stuff into the brain, right? Because what it comes down to is that for a baby, everything is just physical things. Excuse me for a minute. I've got to take a sip. They're just physical and conceptual elements that we know it. And you break them down into individual parts that are like the building blocks of our reality. So, if you take a tree, there's a trunk, it goes into the ground, there's leaves, there's branches, right? You just break everything down. So same thing with our thoughts, same things with our emotions. And when you start to break everything down into these little bit of pieces, they ended up being kind of like the building blocks of our reality. Okay, so you can't just see the big picture of things. You need to break it all down. And these constructs, you can represent anything. So it's kind of like, when you come up with an idea for something, it's not just a word, right? When someone says, "Hey, can you take out the trash?" Right? That's like a construct. And depending on where you at, that has different meanings, and it's not always the same. And, it's kind of like, that's just a construct. Take out the trash, right? And we understand that. But until somebody shows you what you mean by that construct, you have no clue what that is. But you also need to be able to put everything back together. So you can't just break it down into pieces. They all need to go back into the whole. And so that's for every organism, object, process, behavior, event, concept, to what it belongs to. So what kind of data model, data structure is required for this knowledge? And as you can see from this list, right, it's incredible, right? These things don't talk to each other, right? They're all in separate applications. They all work differently. There's no possible way that you can build a mind with all of this, right? That's too big of a mess. I mean, there's just too much work. And then you're interchanging everything and they're supposed to be linked. I mean, that's not going to happen. So I spent a lot of time thinking about this some more. Like, how do I get this data model? What kind of data model do I need? Because I look at all this stuff and I'm like, it's not happening. So the crazy thing is I'm going through an Unreal Engine tutorial on Graph Shader. And all of a sudden it kind of hits me and this chill kind of goes up my spine that, oh my God, this is what I got to do. Not exactly this, but something very similar to this. This is right giving me the ideas that I need, and I need to put it together. So it doesn't, gel right away. It takes me a few more months. And then I come up with this idea called an interlinked construct node. So you know how nodes work, right, in other types of graphs, right? It's just, here's a node, here's an edge. Sometimes the edges are labeled. But, that's not going to help me with all these different information that needs to be created. So what I kind of come up with is these nodes where you can interconnect nodes based on a category, right? So I've color coded them here to make it a little bit easier to understand. So root and derived constructs are number one. That's very much like a class, but as I mentioned, it's not very strict. It's got to be kind of loose. Two are properties or attributes. Three is sensory input or emotions. Four are different types of choices that you have that are presented to you. Five are conditions or prerequisites. Six are end states that happen. Seven are values that kind of like get tied to whatever that needs to be. And eight is sequences. What's interesting is that if you think about our episodic memory and a procedure memory, a lot of that's like a storyboard. And I'm not sure if a lot of people have thought about it that way before. And so when you start to think about, like, as an example, if you were to get up and get out, go to the bathroom right now. I see Michael has his hand up. Hold on a second. You'd actually come up, you could actually create a storyboard out of that. And even with thinking, a lot of it is, you've got a thought process going on, what you want to say or do, what have you. And that starts to kind of create this storyboard of your thoughts, of the information, the questions, those type of things. Michael, did you have a question?
Yeah, just a small thing about the presentation. We can't see the left-hand side of your screen. At least I can't.
I've got it, Michael.
You just have to expand your Teams window a little bit. Mine showed better after I just sized up.
Make it, go to your Teams thing and make it full screen. That's
okay, thanks. Sorry for the interruption. I'll figure something out. Bye-bye.
Okay. And so I'll get a little bit more into the structure here of what this is, but essentially you can
sorry to interrupt again, Rainer, but to your mind, are these linked categories more or less comprehensive? Do they cover the bases or not?
So what I decided to do with my implementation, so in the patent, you can have any number of links that you want, right? But you always need a starting point somewhere. Mm-hmm. So, I like these 8. What it is, it's kind of like a forcing function in a way. I think if you have too many categories, things can quickly get out of hand. I kind of tried to base this on just some of the baby simulator things that kind of came out of it. And these are kind of like the things that I saw. Now, it could be that I need more, that I need 9, that I need 16, maybe it's really 32. But until you start building it all out and you say, okay, it really needs to, I really need to add another thing here. This will do fine. I mean, it's not that hard to add one more. I just think if the more you give, people say, well, why can't you add one more and another one and another one? And pretty soon you've got 64.
Yeah. That makes a lot of sense, and a lot of people in the group today understand that intimately. So, good point.
Okay. All right. So here's just a simple conceptual example. Let me get myself out of the way here. It's going to be this. There we go. So I'm going to start here. So the construct is an apple. Right? This is something that we made up. Nobody said this was an apple. And all these things about the apple we kind of created. So, that we know that the root construct is that it's a fruit. The properties, you've got the variety, you've got the mass, you've got a whole bunch of other properties. I'm just showing an example here. They're connected with values, right? So you've got the different properties of the apple. You got the values of the apple. When you take a look at the sensory input, this is what you see. Right. And when you touch it, this is what you feel. It feels firm. How's the texture? That's something that you look at. When you take a look at how you want to consume the apple, if you want to eat it, right, there's things that you look at. Those are the conditions for you to eat it. And everybody does this, right? Is it ripe, not spoiled? And is it free of any creatures, right? If those conditions are true, then you're going to eat it. Otherwise, if these conditions are false, you're probably not. For you to eat the apple, you've got choices. Right? You can bake it, slice it, you can dry it or juice it. And there are other options here, but these are the ones that I kind of, like I said, once again, just for this conceptual example here. So let's say if I want to slice it, there's steps that I need to go through. But in order for me to slice the apple, I need a knife and a surface. Those are conditions. So, in our head, there is no if then else statement. Okay, that's something, once again, that we constructed, right? The if then else paradigm, because that's how we do it. That's how we think about things. But, if you think about it, it's like, okay, I want to cut this knife and there is no knife. In your mind, you don't say, okay, what's the else statement now, right? You implicitly know what to do, right? And that applies to a lot of things. I mean, if there's no soap when you go to wash your hands, you know, there is no else in your head. There's no soap. This is the path I need to take. This is what I need to do. And so those are the sequences. Okay. When you go to end states, those are the different end states for an apple. It's not comprehensive, but it's either going to be consumed, decomposed, or somehow it's going to turn into a tree. Okay. So this is not really using the, so this describes the linked categories. So you have a general idea of where it's going. And let's step into this next slide. So you can interlink constructs based on the category. And it's pretty straightforward how you link them. Right? You just drag from one node, you pick the category, drag to another, and they kind of describe what it is automatically. So if you're using, you know, a certain pin, you know it's a sequence, you know it's a choice, you know these are properties, right? There's no, you got to read what the edge says. Okay, you kind of know based on the way it's flowing. So there's a flow of the data. So root constructs are always to the left like this. Properties go down. Sensory goes down. Choices are down. End states are down. Sequences go to the right. That's not on the right connection there. That's interesting. That slide's wrong. And the conditions go up. Okay, so this is an ICN graph. So ICN's an ICN graph. I'm going to go to, so you can just connect them as required. There are no rules here. As long as it fits what you're trying to represent, you can just connect it. Okay, and I'm going to kind of step through an example here on how you would do this here. So what we see here is that I'm going to follow through 1, 2A, 2B, 3A, and 3B, so you have a better understanding of how this works. So in order for you to execute sequence 1, conditions 1 and 2 need to be true. Otherwise, you're not going to do it at all. When you come to sequence 1, you've got 2 choices to choose from, and that's if condition 3 is true or condition 4 is true. Once you pick one of those paths, you're going to go through those sequences until you come back to 3. You automatically go to 4. And then with your 4, you're going to have 2 different end states based once again on the condition. So if only condition 5 is true, then it's going to be 3A. And in here, if condition 5 and condition 6 are true, it's going to be end state 2. Or if it's condition 7, it's also end state 2. This stuff can just flow through like this. And you can understand what's going on based on what conditions being chosen, what choices are presented, and how this thing flows through the sequence. So this isn't one of those things that kind of like lay out themselves, right? Somebody needs to kind of put these in here. But the general flow is always based on the category of the way things are done. So it's easy to see that the sequences go from right to left, the choices go down. Once again, you continue with the sequences. The conditions are up like this, so they're easier to read, so you know that there's a condition. Okay. Excuse me.
A couple of questions, one from Doug.
Right. So I think you may have answered my question, which was that essentially every box is itself an ICN node, and it's an algorithm. It's an iterative algorithmic thing. Like you evaluate each of these nodes according to what has been connected to it.
Correct. Correct.
Okay.
And I had a question.
Yeah, that's good.
Sorry, go ahead.
But I'm brewing up another question, but I'll let Michael go.
Yeah, I'm trying to work out what if any significance there is to these colors. So all the white ones seem to be sequences. There's some of the conditions are purple, some are blue. End states are both the same color as each other, but also the same color as choices. And so I'm wondering, is this just kind of pretty colors for the sake of it, or is there an underlying pattern that I'm not seeing?
Okay, for this, it's just to kind of help when I explain it, right? So you can see the separation. Within the application itself, you can change the border of the node if you have a specific standard that you want to follow, and I'll show that a little bit later. But for this particular example, it's just there so it's easier to read. So you can see, kind of see these different conditions, those type of things.
well, okay, maybe you're going to get to this later, or maybe not. But I do need to ask you, how sure are you that that a given graph is actually computable? How sure are you that you can actually wind up with one stable result?
Yeah, what's interesting there is that, you really have to consider the permutations of what you're representing. If those end states are not known, if the conditions are not known, then you end up in a situation where you have to account for that within the sequence. Okay. So, if you're looking at, does it compute? This isn't, it's just completely thinking about it differently. It's very possible that as you go through this, as you're running the simulator, okay, that the interactions and those type of things, you see that you've missed something, okay, at which point you're going to have like, hey, I have no way to resolve this situation. Okay. So it's not always going to compute. I'm going to have to, I can't deny that sometimes things are going to happen
every day, right? Just get to hit a point like,
yeah,
where's my node? Okay.
so yeah, it's true. This is the kind of problem that a computer is going to have, right? Until it lives the life that we do, right? Like I said, you can't just infuse that knowledge there by reading thousands of documents or watching all kinds of movies and, say, what do I do if I turn the corner and I look down and there's a gaping hole? If this is the first time you're encountering it, what do? You try to pull from episodic memory to kind of say, okay, what do I do when I see a hole in the floor like this? So it has to, what is the condition now? I have a hole in the floor. When I look this up, do I have some type of resolution for this? If I don't, then I'm going to have to say, okay, what do I do? Do I try to cross this thing, right? Once again, you look at the choices, right? I can try to cross the hole in the floor. I cannot cross the hole in the floor. What is my objective? What end state do I want to achieve? If I need to get to the other side, do I need to trace back my steps to find another way to get here? So that's, it's kind of, without getting into more detailed example or specific example, it's kind of hard to explain it all. But I guarantee there's times when it's not going to, compute, if that's an okay answer.
Yep, that makes a lot of sense.
Yeah, I think Laura has a question as well.
Yeah.
Yeah, just a sort of a clarifying question. So you don't label the edges of this graph, but each edge seems to have some kind of a category, if I understood this correctly.
That's correct. So what it is that you predefine all your categories before you start representing anything.
So this could be an edge labeled graph where the labels would be those categories.
Correct. But because of the position of the links around the border of the ICN, those are all kind of like the position defines the category. That's why it's laid out in a specific manner. You just don't connect it, right? So now nodes, right, they're just connected. It's like I'm connecting, one node to another. There is no connecting point per se. And so those,
right. I understand, but that's for the graphical representation of this. If I think about this graph as a sort of a mathematical construct, is the orientation of these connecting points, is it significant? Because I figure it's significant in the visual representation.
Yes, they are. So when I store this information, I do specify what link it is on one end and the other end. So there are matching links. So you can't just nilly-willy connect them. It has to make sense. So and the application will tell you when you're trying to connect something that's not. So if you try to connect a process node to a value node, it'll tell you, no, you can't do that. So there's a significance. And hopefully I can clarify that a bit more as I go through some of the examples. Okay.
All right.
Okay. Excuse me for a minute. I've got to. Sorry. So fields inside of an ICN, you can have any number of fields. Once again, I've decided with 3, kind of like as my starting point. There's the construct. There's like, that can be one word, a whole sentence, just a thought, a fragment, what have you. That's the construct there. There's a free text format that you can drop in anything. And you've got a scripting language that allows you to process. So there's the underlying algorithm that knows how to process and read and enumerate through all the nodes. And then you can there's actually a language for the graph itself. So that's always challenging to kind of develop your own language to do graph processing. But that's what I decided in here that you needed to do, because you can't just, they don't just process themselves in a sense, right? So if you need to look at other nodes, you need to enumerate them somehow, right? You need to be able to do some comparisons of values and those type of things. If you wanted to say something, ask something, you wanted to jump here, go there, what have you, right? A lot of that can be accomplished with the scripting language. So if you run into a scenario where it's like, well, how do I do this now? I don't, this doesn't, once again, this is kind of like, what is your data structure, those type of things. So what you end up really is people think that the data and the algorithms are separate. And in ICNs, they're one and the same. So this stuff can process itself. Okay, so you document what you need to document. Some of it is informational. Some of it you can actually execute the graph based on the sequences and those type of things, right? Based on what's triggered. So some of these concepts kind of come from just synthesizing a lot of other work and efforts that have been done to kind of see how do you make this all happen. Okay, so for sensory perception, it's per sensory perception. You want to put that in the individual ICN. So that'd be images, audio, 3D models. Nowadays they're coming out with artificial nose, artificial tongue, those type of things, and that can provide input into these various type of nodes. So before we get to this graph, hold on, let me back up here. Let me show you a couple of things that I have here. Just a second. I'm just going to show you this first. Okay, can you guys see that okay? Hold on, let me see if I can get this a little bit bigger.
There we go.
Yeah, let me see if I get the zoom tool. Okay, so here's a very simple example. The red, so once again, like you said, for readability, you can color the nodes. The colors, it doesn't look at the color as in terms of the processing. I guess you could make it if you wanted to, but in this case, Tommy is the construct. The root construct, he's a person. He owns 2 cars, right? So so this is a triple in here for this example. Sorry, I should have mentioned that. That he owns a car, actually owns 2 of them. It's got a make and a model, right? So Ferraris, he owns a 458 Italia and an F430. And not only does he own it, but he also drives it and belongs to the 458 club. Okay. I'm going to bring up this. I think I need to zoom out to get here. So here's Charles. Right, once again, he's also a person. He owns a car. It happens to be Ferrari as well. And he also is a member of the 458 club. Okay. And if you would do a query, who owns a 458 Italia, it would turn the who into a person as the construct, right? Onza becomes the predicate. 458 Italia becomes the object. And when you pull a query, it would pull something back like this, right? Onza 458, it's a person and it's Tommy and Charles. So this is just one way that you could potentially do it, I guess, that people are more familiar with in terms of using triples. It doesn't have to be done this way at all, but if this is the way you want to do it, you can. It's that flexible. I'm not trying to dictate how you use the ICNs. If you want to turn it into an IRL, if you want to do, your scripting language, you want to use OWL, whatever you want to do, it can accommodate that. So it's basically what's the underlying application, what does the underlying application allow you to do, and how does it allow you to connect things, and does this make sense? So this is something that still needs to be I'm sorry, go ahead.
Yeah, Chris, can you show us the car model again? Or you showed us a moment ago.
Sure, just a minute.
Yes,
you
thank you. So I see a link between the person and the car, which is great. And then a link between the car and the make, which would suggest that tells me what the make of the car is. But the model doesn't belong to the make. The model belongs to the car. And there's no link between the car and the model.
Just a second. So what it is that you don't see the line here, but what it is, remember, these are just properties, right? So once again, the category that I'm choosing here is this dot here on the far left at the bottom corner, and you connect them like this. So from here to here, there's a link. Sorry, from here to here, there's a link. And from here to here, there's a link, right? Because these are the properties and attributes of car. Okay, so they're not connected like regular knowledge graph type nodes, right? This is kind of fitting into the ICN model of how this fits together, right? So from here, from make, it's the value node that it's using. Okay, so the make is a Ferrari. It's using the value node, the model here. Okay.
Here's a simple question. Why isn't model connected to the car instead of to the make?
Isn't model connected to the car? It doesn't matter. Because these are the attributes or properties of car.
Of a particular car or car? It's a particular car, not generic car.
In this case, it's this particular car in this particular graph for Charles. So if this graph would be about Charles, right? It wouldn't be about anybody else.
Right. Okay, that's fine.
Yeah.
All right, we can move on. It's a detail that I don't follow yet, but that's okay. Let's go.
I have to say this particular visualization is a little difficult to understand because of the background line. You know, the grid that's behind it. It's not easy for us to see exactly what, for instance, the car ICN is actually connected to. So it looks like there's from what I see, there's one line going from car to make. But are there in fact two lines, one line from car to make and one line from car to model?
Yeah, what it is, I do have a different color scheme that you can change it so that the background is white. And so you don't have a grid. I mean, there's a whole bunch of options to turn this stuff off.
Yeah. It's just
just
for the purposes of the presentation. It's a little. Yeah, we have to take it on faith that what you're saying is
the way I'm reading it is the yellow things are the properties of car. So this is not like an RDF graph. It's more like a property graph.
Yes. So the thing is that if I put, RDF, prefix RDF in front of these make and RDF in front of model, right? I think that's, so I want to say here, I'm not trying to necessarily translate, right, the knowledge graph that you know into ICNs and vice versa. That's not what I'm trying to convince you of. I mean, this isn't the perfect example. I'll admit that. I mean, it's just kind of tried to illustrate the point. So I understand. So you guys are actually the first people I'm actually explaining this to. I have a really good friend of mine who's been working with me on this, but other than that, so this isn't very polished at all. So these are good questions, and I do appreciate that observation. I mean, even I have a problem with this. That's why I said you can change the whole color scheme, that you can say, well, I don't want this color scheme. I want, white, no grid, make these black instead. So I get it. Any other questions?
One difference with a traditional property graph is that the properties can't have nodes. So here you're much more freeform.
Yes. It's. I mean, there's different use cases for each type of graph, right? Knowledge graph has a specific purpose, and there's all kinds of different graphs, and they serve their specific purposes and use cases. What I'm trying to do is open it up so that you have the most flexibility possible, so that you're not limiting yourself at all. Okay, so I've got to move things along here because I'm looking at the time, and amazingly, a lot of time has gone by. So let me close this. Oh my goodness. Like this, and go like this. And come back up here. So I'm going to show you another graph that I made here for playing blackjack. Okay, I got to slow this down a bit, otherwise it's going to go too fast. And I'm sorry that I'm not going to be able to video. Ooh, playback, here we go, speed. I'm going to slow this down just a little bit more. Okay, and I need to bring up some notes. What did I do with that notes? Just a second. Here we go. All right. Okay. So this is an interlinked construct node. It represents a simple game of blackjack. Wow, is that all breaking up? There we go. It documents step-by-step how a card dealer and two players play the game. The graph can implement, the editor can implement and run the graph, showing the cards dealt, each player's strategy to decide to hit or stand, the outcome of each round, the game statistics. It also shows how in-graph machine learning that's not Python can be implemented to analyze one player's hit stand strategy to obtain a better win result. Okay, so here's an example of it executing the sequences. So it's just going to run through one more time. So this is all you need for a dealer and two players to play blackjack. And so it documents the thought process, everything that's going on. It shows the workspace. So once again, and it kind of highlights all the decisions. Do you see how it's popping in gray? On how it's processing all of this stuff. So there's some underlying code here that knows what to do with cards, right? This would be typical in a lot of games, like any type of game, like how to shuffle, how to deal a card face up, fade down, those type of things. But the rest of it is all happening inside the graph. So it's, doing the math for each card that gets out. And it's kind of running through this flow here. So in a sense, it's like visual coding, but it's also the data. Okay. I'm going to bring up another video here. So this is, these are the things I did early on. They kind of match up with the patent in terms of the functionality. Here, I need to move this. What did I do wrong here? That's what I did wrong. I need to open it with VOC. There we go. That's going to be better. So this is a Starbucks barista example where you can actually, this barista will take orders. You kind of switch what agent you want. You tell it to start taking orders, and it'll just go ahead and do that. So this first example, I said I want a tall vanilla. It says, do you want a cafe vanilla or vanilla bean? Right. So it can kind of resolve that when someone gets that wrong, right? It's like what you ordered isn't on the menu. Did you mean this or that? Right. I can order more than one drink, and it kind of goes through and it repeats the order. It says, is that correct? Okay. Your order be ready at the end of the counter, just like it at Starbucks. So this one, I said, can I get a tall venti frappuccino? I've actually done this before in a Starbucks. Yeah. And the person was very nice about it. It's okay. So even like in here, it says, do you want a tall or a venti? Right. So I'm going to say that I want a tall. Okay. What flavor do I want? Because I didn't say what flavor I wanted. And there's a mocha. Okay. Anything else? Nope. So I'm going to repeat the order and it's going to say thanks. Okay. So I'm going to give you, I'm going to ask for the bathroom code because I'm one of those guys. And I'm also going to ask them when you close. It can answer that as well.
Now, does she misspell your name on the cup at the end?
I can make that happen, right? That every so often, right? Okay, so I got one more example here, right? This is what can I get for you? I want a tall mocha frappuccino. Anything else? I'm going to say, can you make that a chai cream instead? Right? I'm one of those guys. It says, okay, I've changed your order and that's it, right? So these are just examples of, once again, you've got this documented here, right? You're representing what does the barista do, right? What are the choices available to the customer? What are valid orders, right? What are frequently asked questions that someone would ask as a customer, and how do you answer those things, right? So this is, like I said, I did this example like in 2019. I had this up and running quite a few years ago, but it does illustrate, kind of like what you can do with the processing. Okay. Let me close this out here because then we got a few more minutes left.
We have maybe 12 minutes to the bottom of the hour, Rainer, and just wanted to leave some time for Q&A.
Yep, this is going to be my last slide here. ICN Graph, it's a different approach to representing knowledge that, because of the categories, because of how everything is laid out, can be done in a uniform and consistent manner across all scopes of knowledge. So whatever it is you want to do, if we were at a whiteboard and you picked any topic at all, I can ICN that thing out for you. Okay, there's nothing that I haven't been able to ICN yet. But there's always a first time for everything. You can represent knowledge about anything in the universe as we know it. So you want to do the galaxy, you want to do your cat, you want to do stuff underneath your sink, whatever it is, there's a way to do it. There's self-explaining if it's done correctly. I mean, if you don't know what you're doing, obviously it's going to be a mess, right? That comes with any tool that you use. If anybody has a question about it, like we talked about earlier, right, does not compute, right? You need to have some completeness there. And then, of course, you can activate the graph to execute the specific sequences that are in there, right? So depending on what your input source is, whether that be an image, a sound, those type of things, it can be used as a trigger, right? So words can be used, a phrase can be used, fragments can be used, anything. So where I'm at, I think things are going well with where I'm at. I haven't reached my goal yet. There's still lots of work to do. But, it's definitely progress, I think, in the right direction. Okay, questions?
Super. A lot of clarity, a lot of insight in that presentation, Rainer. Thanks for taking the time and putting it together for us. One quick question I have just for starters is, have you been to any chatbot oriented conferences where people are struggling with like the Starbucks example? And it just seems like you've gotten so far along with how you've modeled this versus what other people were doing, say, back in 2019.
I've kind of been keeping this under wraps.
Yeah.
And so my friend who I've been working with, he really twisted my arm to get the patent. He's like, if this is really something, you've got to provide some intellectual property protection. I'm like, oh, come on, man. Why can't we just give this away? He's like, no, man, you really got to get the patent. So I've been sitting on all of this and not really sharing it with everybody. I mean, at LinkedIn, I have some articles that kind of talk about this. And, people think a lot of people don't take artificial general intelligence seriously, right? A lot of people think it's just sci-fi, not going to happen in our lifetime. What a joke, And so if you're doing this, like, they don't listen to you, right? Yeah. Or they've done it before. The interesting thing, I think I posted one of your comments on LinkedIn, is somebody says, well, it's not possible for a computer to reason at all. And I'm like, well, just because you weren't able to do it doesn't mean somebody else can't, So I don't know. It'd be interesting to see what the chatbot community has to say about this. I still need to tie a good language model into this. Right now, I'm doing a lot of text-to-speech and speech-to-text. And some of this is a different approach to natural language processing as well, because some of it is cascading activation. And I don't have enough time to get into that at all. But, a lot of times when you say, like I said, can you take out the trash? I don't need to process that, right? That almost becomes a sight word to me, right? Can you take out the trash, right? You don't have to say, okay, what's the verb? What's the noun, right? That's a lot of unnecessary, right? So if you think about our lives and how we communicate with people, a lot of really simple things that we would tell a robot, like that. Can you do the dishes? Can you clear the table? Those don't require really complicated language models, right? It just needs to take those words, take the sound, turn it into text, find the index value for that, the hash, what does it connect to, right? And execute.
Great stuff. We've got some questions from Doug and Michael and Aura. Doug, you want to start?
Yeah, thanks. So this is super interesting, Rainer. I wanted to ask you, you connect a bunch of ICNs together using your category links, and you wind up with a graph. What choices do you make in terms of the processing order of those graphs, of those nodes? Because that's I mean, in terms of graph processing, that's kind of an unsolved problem, right? What's the right order to execute all that stuff?
Yeah, a lot of it's based on, well, because it's all connected, okay, because I've got the scripting language, what it does is that depending on what you're encountering, you kind of decide what you want it to do. Okay, I'm doing a big programming no-no. I allow go-tos. Okay, not all. Okay, so in some of my graphs, not all the nodes are connected. Right? I don't know if you noticed that at all.
But it's what prompted my earlier question about the computability, because I saw that and I was like, "Ooh, that's a no-no." But maybe it makes sense in this case.
Yeah, I always tell people, I'm not breaking the laws of physics here. If I need to use a go-to to make it happen, I'm going to use a go-to. Okay. So what it is that it follows. So the execution follows if the ICN is activated. So if the node is activated, it's going to process the next sequence unless you tell it to do something else. So if you tell it to wait, or if you establish a TCP connection or UDP connection and you're waiting for a return result, okay, it's going to wait there until that result comes back. And then based on that activation, it's going to do one of those cascading things again. So it knows how to process these things as the input comes in. So whether that's processing itself or from an external source, you basically say what those activations are. So you essentially in the application, you say, I want you to queue up something. Something's going to happen, like the user's answer, or how do I build up this order? I'm going to check this order, right? So after the user tells me what they want in the Starbucks example, it's going to turn around and say, okay, do I have everything? Right? You told me the size, the flavor. Do you want a Frappuccino? You want something else, right? An example is Starbucks. And then if it says that you haven't filled in a blank, it's going to say, well, I need to ask you for this. So it's going to go find the node that says, how do I ask the person for this? And then just execute it. Okay. So like us, right? It's like if you were the barista and somebody said, can I have a tall venti Frappuccino? Right? You say, okay, well, dude, you want a tall or you want a venti? And then you didn't give me the flavor, I'm going to ask you, right? So there's no order to that, right? And that's the problem that people have. It's like, I have data, I have a program and algorithm, I need to apply the algorithm to the data. No, it's one and the same is what I'm saying. Okay, is that once it's one and the same, it's a completely different paradigm that people may not warm up to right away or need more of an explanation. And I get that, I'm doing something very different.
Yeah.
Hope that answers your question.
Super.
Right. Yeah.
Aura? I'm sorry, Michael is first. Michael, you still there?
Yes, I'm on mute. Sorry. Anybody can build a blackjack player or something to run down a list of facets for Starbucks, which is nice. But so what would you say the advantage of your approach is over other things? And what's the core insight that makes it work? What can you do that nobody else can do? And what's the core mechanism that makes that possible? That's a big question, but
Okay. So what I've tried to do is not do everything at once. Okay. So for robot things, there are very things that are very procedural in nature. Okay. When you start to get to more complicated things like reasoning and inference and planning and those type of things, okay, you kind of use that storyboard model to kind of make that happen. Okay, so I don't have enough time to explain that today. So, I mean, as far as what's different, there's so many different projects and so many different things out there that people are doing, right? And right now I really don't want to compare. I mean, I know that's kind of like a crazy thing to say, but it's kind of like, well, why is mine better? And I'm just going to say my approach is different.
That's fine. Thank you.
Yeah. Okay.
Aura?
Yeah, so in a way, this kind of reminds me of some of the work that was done a long time ago, like in the 70s and 80s, where people tried to think about kind of the brain as a sort of a computational thing, like Minsky and Dennett and Sloman and those guys. And I particularly remember like Sloman argued that there's like this layered thing that sometimes you don't have time to do all this thinking. You have to do something quicker, and but yours seems to be sort of a kind of a single layered, almost like single threaded even. So how can you comment on that in any way?
Sure. What it is, and I didn't show this today, is that you can have multiple graphs open at the same time. So it isn't actually a single process. You can actually jump around to other graphs. You can actually pull information from other graphs. So if you have a user graph, you can say, I need the user's name, or I need you to use email address, or I need to use the user's preference from this. So what happens is, if you look at kind of like, even though in our mind things happen, it seems simultaneously, and maybe it does, that there's all kinds of parallel processing going on. You still have these individual steps from one fraction of a second to the next that needs to take place. And if you go through the individual steps, you can all piece it together. So, people are going to say, well, your stuff is a lot like frames, or a lot like, this, like that, whatever. And I get it. So it's almost like, I would say, layers in Photoshop. Okay, you've got multiple layers. You can activate the layers, turn them off, turn them on. In my case, the layers can talk to each other to kind of achieve the end result. Hope that answers your question.
There's an awful lot to explore here, and very stimulating presentation you've put together, Rainer. We're on the half hour, and I just wanted to give permission to others who have to leave. I wonder if you could stay on for a few more minutes. Rainer?
Oh, sure, I can do that.
Okay. Other questions? Michael Sullivan?
Yeah, could you imagine these disparate graphs being federated over rest? In other words, not all in the same compute?
Yes. So if you take a look at device, local server, remote server, and cloud, if you can specify where those other graphs are, you can just pull them in as required. So as an example, driving a car and baking a cake, you don't need that on the same device, right? You're doing one or the other. So it can just swap it out. So some people think, well, you need this massive brain to do it, but you can just, you can just separate it all out, right?
Yeah, it's like putting on your baking hat versus putting on your driving hat.
Correct.
Yeah, cool.
Other questions? How about reactions? And when you're hearing from Rainer, what's your reaction to what he said today? Anybody have any reactions they'd like to share? Give him some feedback on his ideas.
I do, but I'll let other people go first.
Like, you're first up at bat, Michael. Might as well go ahead.
Yeah.
Okay. So my general reaction is, this is very fascinating. You make some very bold claims. It would be lovely if it was true. And don't know enough to make an assessment. If someone said to me, hey, what do you think of that talk? I would say, well, I don't know. It's kind of interesting. So I just want to say I'm looking forward to hearing more about it and what it can do and how.
Thank you.
Oh, there was actually a more specific question, which is, I know someone who might be interested in this, and I was going to forward him the name of your patent, and I Googled the name of your patent, and the only thing that showed up was your LinkedIn page. Is there a way to?
Yeah, I pasted the links in the chat, Michael. I think that.
Oh, all right.
It's also in the email that I just sent earlier.
Okay, thank you. Thank you very much.
Michael, you had a reaction?
Yeah, it seems to me that this is aimed at the citizen data scientist. In other words, you've kind of into one interface allowed someone to kind of sketch their knowledge and also, not just the relationships of steps and data, but also the actual logic behind it. And is that really who you're aiming this at?
So what you got to look at is this. If I ran Google and I had 100,000 people at my disposal, right, I could all tell them this is what you're doing for the next year until it's done, right? If you want to kind of crowdsource some of this stuff and let the experts do it, so people who actually climb mountains, people who fix cars, specific cars, plumbers, those type of things, and you give them an interface that they can use, they can create a starting point where if you met with them or they met with other people, they could kind of help them flush it out until it's complete. So I mean, you could, if you knew how to do it, take other knowledge sources and populate. It's just JSON. And it knows how to kind of like add nodes based on the directionality of the categories. That's a very possibility. But you know, I don't even want to make this overly complicated. You know, I'm not overly complicated. I can look at this stuff and I can read it, I can follow it, and it makes sense to me. And it needs to make sense to other people as well. People who aren't, you know, IT people or data scientists. So, you know, when you talk about explainable AI and someone wants to know, well, how did you, you know, why did you decide I should do this or not do this? Can you show me or can you explain it to me? It's something that, you know, someone can pull up and look at it with their, you know, with somebody else and say, does this make sense to you? Where did it go wrong? Why is it making this decision? You can see it and you could report it up. And if it was your personal thing, you could change it as well. You know, you wouldn't have to go to a professional, whatever. So that was kind of like the goal there.
And it does remind me a bit of 1982 all over again with the advent of spreadsheets, and suddenly everybody was able to start making their own little worlds, basically.
Yeah, if you take a look at where things like, why am I blanking out? Blockchain is going with. If you want to sell your knowledge, okay, whatever you're good at, just imagine being able to put this on blockchain. Okay, to say, you know, I've got a robot now, I need a plumber. I'm going to spend $1 and I've got a plumber. You know, I need help with something else, $1 and it's done. Okay, this makes it possible for kind of people to take their knowledge and distribute it in a very easy way. And even after they've gone and you know, to another place, they can still have this running. You know, you don't lose it. A lot of times when we lose people in life, right, we basically lose their expertise. Now just imagine being able to take your expertise and everything you know and put it all into graphs. So the graph can think exactly like you do. Or if you're a professor and you teach classes and you want to be able to continue doing that, this can actually teach class. Just attach it to the avatar. I'm working on that.
Are you have you provided any debugging? Because I can imagine these graphs get very big very fast. Given the way people think, right?
Yeah, that's always fun.
Yeah. Well, I mean, the analogy goes back to what people did with spreadsheets. I mean, so many of them were brilliant, and so many of them were total messes. So I mean, you know, it's you get both in the same bag.
I agree. You know, it could be a new profession that comes out, knowledge builders using ICNs, that people consult with somebody to say, hey, we want to do this. You know, just like with spaghetti code, they're being spaghetti ICNs, but then it won't run. So because things light up, that's the way to kind of debug it, to kind of see where it's at. You can follow the flow. It started here, it ended up here. You know, it's not like, you know, because I spent a lot of time debugging code. You know, where you're like, okay, what does this error mean? I don't know where you're calling it from. You know, what am I supposed to do here, right? This will highlight, you know, your problem. You know, you end states, the conditions that were met. You just kind of be able to, because there's find and search features that you can find stuff to see where it's at. And people will try. You know, I just hired this entire single graph on how to assemble a Ferrari engine. You know, well, maybe you could have broken it up into sub-assemblies.
The danger with GoTos, of course, is infinite recursion, right?
Yeah, you know, I do that sometimes still too in some of my code. You know, it's like when you got a loop and you forget to, you know, figure out how to exit that loop and that stuff runs. And what you do is you do that hard reset, man. You know, so, you know, everybody has growing pains, right? You're not going to get this right the first day. There's going to be some issues. You're going to learn real quick. Hopefully your robot isn't hammering something into that endless loop, right? And it's basically going to obliterate what that is because, you know,
You're
Well,
gonna make a robot that makes paper clips, and then next thing you know, the whole universe is turned into a paper clip. Right?
I've heard that before. And
yeah.
well, there's some scary stuff we can do with this once this actually works, right? So you think about the good things that it could do for the world, right? There's also the bad things, and I'm fully aware of that. If you want the Terminator, if
Yeah, but
you
you left off the stupid things. The good things, bad things, and stupid things.
Well, here's the way I'm thinking about it, Michael, and just really quickly, we've had this situation with Excel, as you pointed out, and we've got this situation with Tableau where people are visualizing things that don't have any sense behind them. But you could have this pair programming or collaborative approach where you've got people with different kinds of knowledge looking at the same graph, and then you could have this kind of dialogue and get to a better answer with the help of that collaboration. Would that make any sense, Rainer?
Yes, it does. I mean, this stuff does run in a game engine.
Yeah.
Okay. So some of the things I haven't talked about today is that the game engine can actually create a scene based on what you're describing. Okay. So if I say I went to have dinner with my wife, you can actually drop me in a restaurant, okay, and play through what it means for someone to go to a restaurant, right? So the waitress, we're going to sit down, the waitress is going to come, they're going to take our order, right? And so because I'm doing this in a robot, the robot can go to a restaurant as well and experience all kinds of fun things. So to go back to that, what it is that because it's in a game engine, it can be multi-user. So multi-user graphs, they can all be looking at it at the same time and seeing what it's thinking, what it's doing. And like you said, collaborate and say, oh, I think you should be doing this instead.
Yeah.
Make the quick change, run it again, because you can execute specific points in the graph, right? That particular sequence. You can say, I've actually done that with the Blackjack one, where you basically say, I want you to pause here, like you do, regular in code. You say, I want a break statement here. And then you just run up to this point.
Super. Jess, you had a question. I think this may be the last question for today.
Well, it's kind of more of a fun one, but you mentioned your love of sci-fi, and when you said uploading kind of how people make decisions once they're gone, it kind of had me thinking about, uploading your consciousness, right? So is that kind of how you sort of see things like in the future? Like, for example, like I have a great grandmother who was a whiz at like the market and all these financial things, but she wouldn't know how to map out all of her decision making. So is there like, what is, I guess, a way to like kind of upload a consciousness without having to go, like, is there like a way to do that that many people who aren't technically savvy would know how to do that?
Yeah, you'd have to interview somebody.
Okay, so you'd have to interview them.
And kind of ask them the questions, right? So that's all kind of like going back to the days of programmer analysts, right? Where you were the analyst and the programmer. So you talk to the person, and ask them and break everything down. Because once again, everything is really just, a flow chart, a storyboard. Like, why do you make this decision? Why don't you make this decision? And it's interesting when you talk to older people, they can tell you exactly when you know how to ask them. If you just ask them, give me a brain dump, they're going to say, why, they're not going to happen. But if you know the right questions to ask, okay, you can get this out of anybody. I mean, a friend of mine had the HVAC guy show up at his house, and he did all that work, and he said, I don't see, how are you going to do this with an ICN? And I said, go ahead. Sorry.
Oh, sorry. Because like another way you can do it is like maybe having to interact with a loved one, not maybe in a technical expertise, but it's like, how, like if you talk to someone who's older, like upload their consciousness, quote unquote, you can still have conversations with them, maybe after they're gone, just like, okay, I have this problem, how would you approach it, kind of thing like that. Maybe
I think it's a maybe. That if you want to say, how do you feel about this? How would you do this? How did you do this? Right. So once again, getting back to episodic memory, how did you do this when you had a problem with this particular aspect or this particular thing? I mean, if you got a grandparent who's exceptional at gardening or knows cats, or any particular subject matter, if they're willing to sit down with you and document it, right, you can do it. I mean, it's there, and you can test it with other people while they're still around and say, hey, today I ran into a node that, was like a dead end. I need to ask you a question about something, right? And you just keep on filling that out. So, yeah, I don't think there's ever going to be a time that you can upload somebody's consciousness, despite what Elon thinks he can do. I mean, what you end up with is basically a copy machine version, sort of. Okay. Now, because I don't do brain chemistry and I don't do emotions, right? Some of those things are going to be missing in that interaction. You could fake it if you wanted to with ICNs, because there is that emotional component into it. You can put emotional intelligence into this. How did somebody feel when they didn't pass the test? Why are they feeling anxious before the test, right? All those things you can account for with ICNs.
Yeah.
Very cool.
Thank you.
Well, thanks so much for the presentation, and you stimulated a lot of good discussion. We're going to be posting this